Okay guys, continuing with the 5.4 notes, day 1. This bottom section I threw in here as a review. Now, in chapter 4, we talked about special triangles and how to use those instead of the unit circle. I asked you to memorize the lengths of the sides, so in case you forgot, here are the special triangles again. I also talked about quadrantal angles, the ones that land exactly on the x or the y-axis, and how you had to know those coordinates. And not only that, but that the x value in an ordered pair corresponds to cosine of an angle, and that the y value corresponds to the sine. You also had to memorize that tangent of theta is sine over cosine, aka y over x. And remember that when you're talking about quadrants, signs are important. So you also had to keep, in the back of your mind, the signs for any ordered pair that lands in each of those quadrants. Feel free to write this down, so pause the video if you need to, but all of this stuff are things that we learned in chapter 4 and you're going to need them again. So if you haven't memorized that yet, you better memorize it now. Okay. Find the exact value of each expression. Sine of pi over 6. Pi over 6 is the equivalent of 30 degrees. Pi over 6 is 30 degrees. Pi over 3 is 60 degrees. Pi over 4 is 45 degrees. And pi over 2 is 90 degrees. That you guys talked about in advanced algebra. We also talked about it in chapter 4, but those are really important things to have memorized because we're going to keep going back and forth between radians and degrees. I know most of you are most comfortable with degrees. Okay, so the way we did these problems is we first drew the angle. So pi over 6 is 30 degrees. So that would land in quadrant 1. This is 30 degrees. Drop the height down to the x-axis. Remember, we always use reference angles. Reference angles are always from the terminal side to the x-axis. They have to be positive, and they have to be acute. Okay, so that means this is a 30, 60, 90 triangle. Fill in your sides. In quadrant 1, all your signs are positive for x and for y. So this is plus plus. So cosine and sine are positive. Now they asked me for the sine of pi over 6. So I know my answer is going to be positive. And sine is opposite over hypotenuse. So using my triangle, I'm going to take opposite over hypotenuse, reduce if possible, or rationalize, and I get 1/2. Pause the video, rewind, and do whatever you need to do in case you feel like I explained something too quickly. I am going to go a little quickly on these since we technically learned this in chapter 4. Okay, to find the secant of 11 pi over 2, I'm going to graph the angle first. So remember that pi over 2 is 90 degrees. So this would be 2 pi over 2, because that reduces to 1 pi. This would be 3 pi over 2, 4 pi over 2, which would be 2 pi. So if you think about it, this guy would go a full circle to 4 pi over 2. then another circle to 8 pi over 2. Then from 8 pi over 2, we'd go 9 pi over 2. So this would be, remember, one full circle is 4 pi over 2. Another full circle is 8 pi over 2. This would be 9 pi over 2, 10 pi over 2, 11 pi over 2. So we'd end up right here. So if I were to graph it, my terminal side would be on the y-axis. That's a quadrantal angle. For quadrantal angles, we need the ordered pair. So this is 0, -1. This is your cosine. This is your sine. Normally, secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse, so secant would be hypotenuse over adjacent. However, I can't draw a triangle when my terminal side is in a quadrantal angle. So you just have to use the reciprocal of cosine. So secant is 1 over the cosine of the angle that was given to you. The cosine is the x value, so if you look, the cosine was 0. So I'd have 1 over 0, which is undefined. -2 pi over 3. Remember that pi over 3 is so pi over 3 is 60 degrees, okay? So whatever the denominator is, I don't know if you guys remember, whatever the denominator is, that's what I would tell you to cut each half of the circle into. So 3 parts, 1, 2, 3. And each of those would be 1 pi over 3. Now I'm going down and around because it's negative. So this would be -1 pi over 3, -2 pi over 3, -3 pi over 3, which makes sense because this 180, right, always is equivalent to pi. So add that to the list for radians and degrees. 1 pi is 180 degrees. Things that you need to make sure you know. Okay. So I used to use dashed lines when I would graph, or when I would split each half of the circle into 3 portions because the denominator was 3. But when I graph the angle, initial side, terminal side. Okay, so now I need to find the reference angle for -2 pi over 3. Remember, your reference angle is always to the x-axis. It has to be acute, and it has to be positive. So I always draw my height to the x-axis. I want to make sure that I use this as my reference angle and not this guy, because this guy is definitely not acute. Okay, so this is going to be my reference angle. Your reference angle is the distance between the terminal side to the x-axis. So -2 pi over 3 is 1 pi over 3 away from -3 pi over 3. And as I mentioned earlier, pi over 3 is 60 degrees. So your reference angle is 60 degrees. And remember, your original angle was this guy here, was 120. -2 pi over 3. Now remember, how did I know that was 120? I graphed by pi over 3. I know that pi over 3 is 60 degrees, and 180 minus 60 is 120. If you want to, you can always convert all radians to degrees by cross-multiplying. So -2 pi over 3. If you want to change it to degrees, you just do there's your radians. You want to know how many degrees it is. So pi is 180. and then cross multiply and solve. Okay. For a 30, 60, 90 triangle, which is what this is, you want to find your side lengths. But remember that in quadrant 3, the signs are minus plus, minus for cosine, sine is positive. I wrote that. It's minus, minus. Pew. Cosine and sine are both negative. Whenever you go to the left and down, your values are negative. That was the number one mistake that happened on your test, is in your chapter 4 test. A lot of you guys forgot your signs. Okay, now remember to the question at hand. Remember back. They wanted the tangent of negative 2 pi over 3. So I graphed negative 2 pi over 3. I realized that the reference angle was 60. That helped me draw my special triangle. I filled in my side lengths, keeping track of my signs. And now I'm ready to answer the question. Tangent is sine over cosine, or opposite over adjacent in a triangle. So opposite over adjacent you're going to use if they give you a triangle. Sine over cosine is what you're going to use when it's a quadrantal angle, if it lands exactly on the x or the y-axis. So if you have a triangle, you're going to look opposite from the 60, which is negative root 3, and then over adjacent, and then reduce. Okay, go ahead and pause the video. Graph 3 pi over 4 and find the reference angle. Push play when you are ready. Okay, since the denominator was 4, I cut this half of the circle into 4 pieces. Now 3 pi over 4 is going to end up in quadrant 2. And the reference angle is going to be this guy here. So I'm going to drop the height down. 3 pi over 4 is 1 pi over 4 away from 4 pi over 4. So the reference angle here is pi over 4. Now remember, pi over 4 has a reference angle of 45 degrees. So this is a 45, 45, 90 triangle. The side lengths are 1, 1, root 2, but in quadrant 2, the signs are minus plus. When you go to the left, your x value is negative. When you go up, your y value is positive. Remember, the hypotenuse is always going to be positive. So you don't have to worry about the signs there. Now, cosecant is the reciprocal of sine. I would use that if it was a quadrantal angle, but because I have a triangle, I can use opposite, adjacent, hypotenuse in those words. So cosecant is the reciprocal of sine. Sine is opposite over hypotenuse, so cosecant is hypotenuse over opposite. So from the 45-degree reference angle, I'm going to choose the hypotenuse over opposite and reduce. Okay. Later on in Chapter 4, we learned that there are restrictions for the arc cosine, aka inverse cosine, aka cosine to the negative 1 power. So cosine inverse is restricted to quadrants from quadrants 1 and 2. So from negative 90 oh my gosh, I totally said that wrong. Negative 90 to positive 90, that's quadrants 1 and 4. Tangent inverse is restricted to, oh Lord of Jesus, help us all. This is what happens when I make the videos late at night. Let's try this again. Okay. Whew. Cosine inverse, or arc cosine, is restricted from 0 to 180. That's quadrants 1 and 2. Or in radians, from 0 to pi. Tangent inverse and sine inverse, aka arctan and arcsine, are restricted from quadrants 1 and 2. So you can go down to negative 90 and up to positive 90. Or in radian, from negative pi over 2 to pi over 2. So write this down somewhere so you don't forget. Okay, now cosine inverse, if you look at number 10, they're asking me to find the cosine inverse of root 3 over 2. So cosine inverse is restricted to quadrants 1 and 2. So what we need to do is we need to figure out, okay, well, they gave me a positive ratio. So would it be quadrant 1 or quadrant 2? Cosine is the x value of an ordered pair. And since theirs is positive, that automatically means that it's got to be quadrant 1. Remember that in an ordered pair, the x value is cosine, the y value is sine. So since the cosine is positive, I'm looking for which of these quadrants has a positive x value. That's why it's important to know the restrictions. Okay, so that means that I'm definitely in quadrant 1. So I'm going to go ahead and draw my triangle. And here's my reference angle. They're telling me that cosine is root 3 over 2. So that's adjacent over hypotenuse. So adjacent to my reference angle would be root 3. Hypotenuse would be 2. Now this is a 30, 60, 90 triangle. Adjacent from the root 3 is the 30 degrees. So that you have to kind of figure out. Remember, root 3 is always across from the 60. Across from the 30 is a 1. None of these are negative because you're in quadrant 1. So this is the triangle they wanted you to draw. They asked you here, what is the cosine inverse or arc cosine of root 3 over 2? Whenever they use inverses, they're asking you for an angle. Okay? So anytime they say, what's the cosine inverse or the tangent inverse or arc cosine, arctan, they're asking you for an angle. That was another thing that was really rough the last time you guys took your test. Some of you guys were giving me a ratio when you should have been giving me an angle. Okay, so the angle is 30 degrees. However, they want the answer in radians. So 30 degrees is equivalent to pi over 6. Tangent inverse is restricted to quadrants 1 and 4 because I'm restricted between negative 90 and positive 90. And if you look, they're saying that the tangent is positive 1. So think about your ordered pairs. Cosine, sine, cosine, sine. Now tangent is y over x. So if your answer is supposed to be positive 1, your fraction either has to have 2 negatives or no negatives at all. That means that this has to be quadrant 1 because positive divided by positive would be positive. Positive divided by negative, that wouldn't work. Sorry, you're supposed to be doing y over x. So sine negative over positive. If you divide those, sine over cosine, that would not give you a positive. So we're at quadrant 1. You're going to draw your triangle. Here's your reference angle. Tangent is y over x. Also, you guys know it as opposite over adjacent. You have to be able to go back and forth between these two concepts. That tangent can be seen as sine over cosine. It's the reciprocal of cotangent. It's also opposite over adjacent. So opposite over adjacent has to be 1. So this is a 45, 45, 90 triangle. Your angle that you were trying to find is 45 degrees, but in radians, it's pi over 4. Okay. Sine inverse is restricted to quadrants 1 and 4. It has to be between negative 90 and positive 90. And you got to ask yourself which of these it would be. Remember, it's cosine, sine, cosine, sine. Since the answer is negative, since sine is negative, that means that I'm looking at quadrant 4. So I'm going to draw my reference angle, theta. And that sine is opposite over hypotenuse. So from my reference angle, it's opposite over hypotenuse. Remember, hypotenuse is never negative, but when you go down on the y-axis, that will be negative. So this one has to be negative. And you should already start recognizing that this is a 30, 60, 90 triangle. And our reference angle is 30 degrees. Across from the 30 is a negative 1 in this case. Across from the 60 is root 3. And there's your triangle. And that's what they wanted you to find. What angle has a sine that is negative a half? That angle is 30 degrees, but in radian, and sorry, it's negative 30 because we went down, right? In quadrant 4. Remember, you're restricted between negative 90 and positive 90. So negative 30 degrees would be negative pi over 6. All of these ideas are so, there's just so many things you have to remember, guys, but the only way to get better at it is to keep practicing. Feel free to email me or send me a message to remind if you want more examples. Keep me posted. Good luck.